Hello, my name is Janus Varmarken. Thank you for attending our presentation of our paper, FingerprintTV, Fingerprinting Smart TV Apps. This is joint work with Aaraj, Rahmadi, Trimananda, and Professor Athina, Markopoulou. A smart TV, also known as a connected TV, is an internet-connected TV with computational capabilities. This allows the TV to download content from servers on the internet and run interactive apps. Smart TVs come in two flavors. There are built-in smart TVs, where the hardware and software is integrated into the TV set, and there are external box or stick solutions that can be inserted into a TV, and we refer to both of these as smart TVs. In this work, we study network fingerprints in the context of smart TVs, and simply put, network fingerprints are traffic that is characteristic for certain software or hardware. And by observing the manifestation of fingerprints in real-world traffic, one can then deduce that the corresponding software is being used. Now, well-studied classic examples include identification of websites and IoT devices, but smart TV app identification has received less attention in the literature. There are many different network fingerprinting techniques, ranging from simple port-based fingerprints to sophisticated deep learning on traffic metadata. In this work, we consider three techniques that roughly fall in the middle of these two extremes. Smart TVs are now widespread in the US, with at least one smart TV in 82% of US TV households. At the same time, more and more users rely on their smart TVs for entertainment in general, including for music, for video, and for social media. So this technology is used by many people, often for several hours a day. And partly due to this scale, smart TV app usage data has monetization potential. From studies on smartphones, we know that app usage is indicative of the user's demographics, personality, interests, etc. Now, assuming that this carries over to smart TVs, and also considering that viewing history is regarded a cornerstone of programmatic TV advertising, smart TV app usage data is arguably a treasure trove of information for businesses engaged in targeted advertising. And because ISPs are known to collect and use information about their customers for advertising purposes, we believe it is important to quantify to what extent that they can collect smart TV app usage data as well. Thus, the research question we set out to answer in this study is, to what extent can smart TV apps be identified from their network traffic? To answer this question, we take a network measurement approach in which we instrument smart TVs to repeatedly launch the top 1,000 apps of the three most popular smart TV platforms, namely Apple TV, Amazon's Fire TV, and Roku, and we then analyze the traffic the apps generate for network fingerprints. We instrument and collect traffic from the smart TVs by configuring a computer to host a wireless network. The smart TV under test is then connected to this wireless network. And this means that all traffic generated by each app under test will therefore flow through the computer's wireless network interface. Finally, we run our software, FingerprintTV, on the computer. FingerprintTV automates collection of apps' own launch traffic. For each app, FingerprintTV programmatically installs the app on the smart TV, launches the app 10 times while collecting traffic on the computer's wireless network interface, and ultimately uninstalls the app from the smart TV. In the following slides, we'll use the term launch sample to refer to a single recording of the traffic an app generates at launch. To answer a research question, it is important that we study many of the most widely used smart TV apps. We therefore first crawl the web interfaces of the three platforms' app stores to determine all available free apps. For each platform, we then selected the 1,000 apps with the most reviews for inclusion in our study. Now, the assumption we make here is that apps that have the most reviews also have the largest user bases and are therefore the most important apps to test. These top thousands account for 26%, 15%, and 7% of the available free apps for Apple TV, Fire TV, and Roku, respectively. We use three different fingerprinting techniques to extract fingerprints from the collected launch samples. Each of these techniques essentially examines if a specific traffic feature assumes the same value across all 10 launch samples. The requirement that the value should stay consistent across all launch samples is a conservative choice we made in order to ensure that we extract the most reliable fingerprints, but this can be adjusted downwards if so desired. We refer to the fingerprints extracted by the first technique as domain-based fingerprints, or DBFs for short. And a DBF is essentially the set of domains that are consistently contacted at app launch time, as extracted from DNS, TLS-SNI, or HTTP. The second type of fingerprint we consider, we refer to as packet pair-based fingerprints, or PBFs for short. The basic idea here is to identify request-reply packet exchanges where the packet sizes and the packet directions are consistent across launch samples. This technique stems from our prior work, where we found it to be successful at fingerprinting events on IoT devices. Finally, we consider what we call TLS-based fingerprints, or TBFs for short, and a TBF is the set of individual TLS fingerprints that consistently appear at app launch time, where an individual TLS fingerprint is derived from the parameters that the client sends when initiating a TLS session. To evaluate the performance of the three fingerprinting techniques, we look at the following three metrics. Prevalence, which is the percentage of apps that exhibit a fingerprint of a given type. Distinctiveness, which is the percentage of apps that exhibit a fingerprint of a given type, where that fingerprint is distinct from all other apps' fingerprints of that same type. Finally, we examine fingerprint sizes, defined as the number of members in a fingerprint. So for example, the number of domains in a DBF. To compute these metrics, FingerprintTV constructs a matrix where the columns are apps and the rows are fingerprint members. A cell in this matrix is assigned a binary value that denotes if the fingerprint member is part of the corresponding app's fingerprint or not. So for example, here on the right, an app's DBF is the domains corresponding to the blue cells in the app's respective column. Now with this, we can easily compute the prevalence using the number of columns where there is at least one cell that is non-zero, and an app's fingerprint size is just the number of non-zero cells in the app's respective column. To compute distinctiveness, we perform agglomerative clustering on the columns in the matrix, and here we use cosine distance for fingerprint similarity and a distance threshold of 0 when extracting clusters from the clustering. Now this implies that apps must have identical fingerprints to end up in the same cluster, and we can therefore use the number of singleton clusters to compute distinctiveness. We find that DBFs, PBFs, and TBFs are highly prevalent on all three smart TV platforms. For example, all Roku apps exhibit all three types of fingerprints. However, an app's fingerprint is only useful if it is distinct among other apps' fingerprints, and TBFs therefore have little value. Now, this lack of discriminative power is consistent with findings in prior work. We also examined the effects of combining fingerprints, and here on the right, the OR case refers to apps that have either a DBF or a PBF or both of them, and the AND case refers to apps that have both a DBF and a PBF. We see that if one is okay with using either a DBF or a PBF, nearly all apps on all platforms can be fingerprinted, and the fingerprints have high distinctiveness. And the distinctiveness increases even further for apps that exhibit both a DBF and a PBF. To give insights into the distribution of fingerprint sizes and the relation between a fingerprint size and its distinctiveness, FingerprintTV plots the fingerprint size against the cluster size, annotated with the number of apps that fall at each point in this matrix. We see that apps with larger DBFs generally fall in singleton or small clusters, which is what you'd expect, as a larger fingerprint is more likely to be unique. On all three smart TV platforms, the median size of a DBF is 4. The median size of a PBF is 2, 4, and 5 for Apple TV, Fire TV, and Roku, respectively. More interestingly, we find that a very large fraction of the fingerprints that are larger than the median size are distinct fingerprints. So in total, we see some correlation between a fingerprint size and its distinctiveness. To better understand why some apps exhibit identical DBFs, we took a closer look at apps that end up in the same cluster and thus share the same DBF. Here we show a breakdown of the number of distinct developers responsible for apps that cluster together. We found that in many cases, apps that share the same DBF often stem from the same developer. From examining the domains in DBFs that are shared by multiple apps, we also discovered that many apps that were officially published by different developers were actually generated using the same no-code toolkits or developed by the same consulting firms. If we consider such cases as the same developer, a very large fraction of the Apple TV and Fire TV apps that share their DBFs with other apps only shared with other apps from the same developer. In summary, we performed a large-scale empirical study of the effectiveness of 3 different fingerprinting techniques when applied to smart TV apps. We found DBFs and PBFs to be effective at fingerprinting smart TV apps, especially when these 2 fingerprinting techniques are used in conjunction. On the other hand, TBFs have very little discriminative power. We also found that when multiple apps share the same DBF, these apps often stem from the same developer or have been built using the same no-code toolkit. Thank you for listening. Please visit our website where you can access the network traces we collected as part of this study, and we also plan to release the code for FingerprintTV at a later date.